This is a series of questions on momentum, and this is a question, quite an old question from January 99, AS1, and it's question 2. A person of mass 70 kilograms training for a parachute jump but not wearing the parachute steps off a platform and drops 3 meters vertically before landing on firm ground. Show that if air resistance is neglected, the person reaches the ground with a speed of 7.7 meters per second. So this is just an equation of motion question. You know that they step off the platform, so initial velocity is equal to 0. They'll fall with an acceleration 9.81, and we know the distance they drop is 3 meters. And therefore, the equation that we're going to use, that's all written here already, is v squared equals u squared plus 2as. So therefore v squared is equal to 0 plus 2 by 9.8 by 3, and v gives you 7.67 meters seconds to the minus 1. Part B. On landing, the person bends his legs so that his feet remain in contact with the ground. Find the change of momentum experienced by the person on landing. So when they hit the ground, their final velocity is equal to 0. And we know just before they came to rest that the initial velocity from the last question was 7.67, and we know their mass is 70. So change of momentum there is given by mv minus mu, or I've just written it m on v minus u, and since v is 0 we end up with u m times minus u, or m times u, because it's a change. So 70 times 7.67, you could say minus 7.67 if you wanted, and the answer then comes out to be 537 Newton seconds. As a result of bending his legs, the centre of mass of the person's body moves 0.58 metres downwards during the impact. Find the duration of the impact. So now we're talking about the centre of mass of the body moving that distance there, 0.58. And we can assume that they're still falling with acceleration due to gravity. So, well, that's kind of irrelevant because we already know the final and initial momentums. We know the distance travelled, and so we're looking for a time, and so we're using equations of motion again. And the equation that we're going to use there is S equals a half u plus v times t. And then t is, when you rearrange that, 2s on u plus v. So when you put your numbers in, you know that they're starting off with this velocity of 7.67 and ending up with 0. And so it's 2 by 0.58, which is the distance, divided by 7.67 plus 0. And that gives you an answer of 0.151 seconds. Hence, for example, by using your answers to B, the answer to B was a change of momentum, was 537. And C part 1, we know the time, it's 0.151 seconds. I'm just writing those down there. Find the average resultant force on the person during the impact. And therefore, we're just going to use our change of momentum question equal to impulse. So we know impulse is Ft, and it's equal to the change in momentum, which I've written over here as delta P. And therefore, the force is going to be equal to the change in momentum, which is 537, divided by the time, which is 0.151. And that gives you an answer of 3,551 newtons. Hence, taking into account the person's weight, find the average upwards force exerted on the person's feet by the ground during the impact. So the first thing I've done here is I've calculated the weight, and the weight is 70 times 9.81, which is equal to 686.7 newtons. W equals mg. And then we already know that the resultant force, that's resultant force there, the 3,551. And the resultant force, I drew a wee picture at the side here. There's the resultant force there, an upwards force. And that is as a result of this force, take away that force. So this is the force on the person's leg that we're looking for. And so you have 3,551 is equal to that upward force, take away the weight, and so you just end up adding this on to 3,551, and you end up with an answer of 4,238 newtons.